Hello everyone, and welcome to this short introduction to the upcoming video. In this video we're gonna see how to remove an offending reflection over an actor glasses using different techniques. We'll see how to generate a point cloud and a mesh from a moving object, and we're gonna see how to use that mesh and to project onto that mesh to extract a UV texture that we're gonna use as a replacement plate. We will also briefly analyze a potential way of using copycat to hard direct different features of an actor face. Hope you enjoy, and see you later. Hello everyone, and welcome to another video where we're gonna focus on reflection removal in Nuke. I got inspired by a recent video released by Shonda on her post series, where she's focusing and she's sharing some techniques and some tricks as well about how to remove reflection from glasses. And it's a very nice one. There are a lot of tricks and useful tips along the way. So I definitely recommend you to check this out and check the old post series. I'm learning a lot from Shonda, so thank you for that. Thank you for sharing. And the other highlight I would like to say is that she's also sharing like very nice insights about how to, balance professional life and personal life and all sorts of things related to our industry. So it's not just tutorials. She's sharing very nice posts on LinkedIn as well. So definitely check her contents. They're super useful. But yeah, anyway, I got inspired by this tutorial here, and I said, okay, let's see what we can do with a pretty nasty reflection to remove. And that's technically not a real removal. It's more likely a rebuild, okay? Because we need to basically rebuild this portion of her face or of her eye. But before diving into the script and what I've done, some ground rules. First of all, I didn't spend time in finding the perfect asset for this shot, meaning that we're working with plates like this one, for instance, and this one is the plate that we're gonna use to rebuild the eye of this actress here. And obviously, as you can see, these are two completely different plates. They are not lined up in terms of camera angle, lighting, motion. So this is definitely not a right candidate to extract any texture because it's much different from the destination. But again, I decided to try to flex as much as possible Nuke's nodes and see what we can get out of them without investing too much time in finding the perfect candidate in terms of plates and asset. Okay, so that's the first thing I wanted to mention. The final result is not going to be 100% accurate, mostly because of that. Okay, because I didn't spend time in finding the perfect candidate for this shot. I just wanted to see how much we could do with what we have, even if we don't spend too much time in finding the right asset. And that's wrong. We should do it. We should be more mindful about the plates that we're using. But I wanted to see what can I get out of random plate by using different techniques. And again, the result is not perfect and is not working 100%. There is definitely some problem, and we're gonna see some interesting things, I guess, along the way. So let's start from the beginning. Okay, so before diving into all these steps, we are gonna analyze a bit the problem that we are facing. So we want to remove this big reflection, okay? And that's not easy for different reasons. First of all, the reflection is covering quite a lot of her skin and her eye. And unfortunately, if we shuffle through the different channel, we don't have a clean channel that we can somehow use to extract texture or matte or stuff like that. So this element here, this offending reflection is, you know, on every channel, and it has some texture baked in it. Okay, so you can see that it's not just a plain white or bright color, it has some number. This actress is she's probably checking some document on this iPad or tablet or whatever, and we can see that in the reflection we have texture baked in it. So we may attempt, or we may try to recolor this, but the problem is that we're not gonna get rid of this number and the texture that it's in the reflection, right? So that's not gonna work. Now, a second attempt could be, well, I can just steal a portion of this skin texture here and move it there, right? And then with some color correction and then, you know, some grading tricks, I can match it closer with the skin in this area. And then that could potentially work, but the problem is her eye, right? Because we can steal this portion of her eye, but due to the perspective of this shot, this eye here, even if we steal this section and we flip it, we mirror it, whatever, is gonna cover just as much of her eye here. So we're gonna have to rebuild this section anyway, right? So the punchline is we may try to steal portion of her texture and try to rebuild as much as possible, but the problem is that it's not gonna give us a comprehensive solution. We still need to cover certain area with other texture, and at that point it's more convenient to steal entirely another eye. Okay, and as I mentioned before, this is not the right candidate. It has a lot of motion blur baked into the plate. See, there is quite a lot of motion blur because this plate, in this plate, the actress is moving more than this one, so there is a lot of motion blur in the texture that we want to extract to cover the reflection here. Another reason why that's not the right candidate. But as I said before, let's pretend that this is a ground rule and we are not caring too much about the asset, we are caring about the technique. Okay, cool. So another problematic area to consider is the glasses and the frame, but that's not a big deal. We can easily roto our glasses like I did here, and then we can comb them over everything else. Okay, so that's not a real problem. All right, so now that we understood why we want to use a different texture, okay, because stealing portion of our texture may not cover or may not rescue the entire area, flipping portion of our eye is not covering or is not fixing the entire eye. So the most obvious alternative is let's steal a eye or a portion of face from another talent and somehow let's stitch this on this. Okay, now we are facing some challenges here because this actress here she's moving quite a lot and we don't need any motion. We want the texture to be static so that we can then track it on top of this talent here. Okay, and in this case, you know, there is a slight camera movement and she's also tilting a little bit her head, but that's fairly easy. We can just, you know, place some tracker. That's what I did here. I just tracked her, this portion of her face. We're gonna see how I use this tracking data later, but just to mention that, you know, the motion here is fairly simple to track and stabilize. In this case, for this plate here, is not that simple. So how can we get rid of the motion that we have in this plate, both the camera motion and the motion of the actress, so that we end up just with the texture of her face? Well, the first attempt that came to my mind was to use a reverse camera tracking. So what I did here was drawing a simple roto shape that is basically following roughly her face, okay? And then I created a camera tracker, and I set in the mask tab here, I set to use the mask alpha inverted so that the feature of or the trackers are actually focusing on the motion of her face, and they're not considering the relative motion of the environment. Okay, and then I did a simple track and solve approach, and I ended up with this point cloud here. Okay, so if we view it through the camera, we see that we have a bunch of points that are moving as the actress face. Okay, so basically the points are stable and the camera is moving instead. Okay, so the camera is basically replicating the motion of the face of the actress. Okay, so if I see it here, we see that, let's close that, see that the face is moving up and down, tilting left and right, and the camera is basically replicating exactly the same motion. Okay, and we can also view this point over over the actress. Okay, so if I set this to scene over dot and I lock my camera, I can now basically wipe in between the point cloud and the plate, and you can see that the points are sticking there, right? Now the idea here is basically I want to project the texture, I want to project this plate here on top of something that is sticking to her face, and in this case we have a point cloud that is sticking to his face, but obviously, I mean, we can project over a point cloud, but since it's not a continuous geometry, it's not a continuous mesh, we're not gonna get any useful texture out of it. So we want to replace this point cloud with the mesh that is approximating the face of this actress so that we can project our texture on top of that. Now, since this point cloud that comes out of the camera tracker is not very highly detailed, I decided to use a PointCloudGenerator to create a more dense point cloud, and this is helping us to check how the tracking is behaving. So I have this point cloud here. This PointCloudGenerator is basically creating a fairly dense point cloud that we can see through our camera. There we go, right? So basically here we have a 3D representation of the face of our actress. And again, if we lock our camera and we set our wipe to wipe between this scene here, and the dot 11 that is our main plate here, okay, we can check that our dot are sticking to the face of our actress. Okay, and obviously we are also carrying some of the background inside our point cloud, but we're gonna get rid of it in a second. Okay, now for those of you who are curious about the setting in the point cloud, this is literally just the default setting. So I basically analyze the sequence and track the point, and didn't change any parameter in here. I literally just went through step by step. The only thing that I set was the ignore mask, and you see that there is a mask here that is plugged to the same roto that I used for the camera tracker. Okay, that's the only thing I've done other than following step by step the different knobs that we have in this node here. And then when I wanted to basically extract a mesh out of this point cloud, for the same problem that we mentioned before, we want to convert our point cloud into a mesh so that we can project something on top. We can do it inside the point cloud, and let me turn off the wipe. If I switch from a node selection to vertex selection, and I can now select the lasso selection, I can basically select a bunch of points that I can then convert into a mesh. Okay, so I can assign this point to a group by selecting them and then click on create group. So in this case, I created a group named face that is basically just the points that are belonging to her face. So I basically excluded all the background and the hair and stuff like that. And once you have this selection and you create a group, you can bake that selection into a mesh. And that's exactly what I did here. So here we have a mesh that is basically, let's just close the point cloud and let's switch back to node selection. And let's also turn on the light in the viewer so we can see some lighting. Okay, so this is basically the corresponding mesh to the point cloud that we created before, right? Now, this is another, let's say, another ground rule that I want to mention. At this stage here, once you have a decent point cloud that is representing the distribution or the feature of the face of your actor, you may want to import a clean mesh with a clean topology. Okay, in other words, this mesh here has a very messed up topology because it's based on a point cloud. So instead of baking out the mesh from your point cloud generator, it's probably more convenient and more accurate to import a proper mesh, a generic head, or a generic 3D face, okay, that you can basically position based on this point cloud. Okay, you can line up your mesh to the point cloud, okay, so that all the features are lined up as best as possible. And the advantage of that is that, you know, you're working with a clean mesh and not this like screwed up topology that we have here. Okay, we have a lot of polygon and it's not very accurate. But again, I just want to see where I could go just by using Nuke nodes. Okay, I didn't want to import any external asset. I just wanted to use Nuke nodes to finalize this shot. So we have this mesh here, and you know, it's again, it's not extremely accurate, and it has some problem. Another reason why it may be more useful to import an external mesh with the proper topology is that this mesh doesn't come with UV attached. Okay, so if I use an apply material and I want to apply, I don't know, a checkerboard to this mesh, so I do it here, and then I view my apply material in the viewer, and I don't see any texture. Okay, and the reason is that this mesh doesn't have UV. Okay, so in order to fix this, we need to use a UV project, and we need to set the projection to something like planar. So I'm basically projecting UV through this XY plane. And now if I plug my apply material here, I can see my texture. Okay, so again, this is, if it happens to you that you're using a mesh that you're baked out of a point cloud or something like that and you don't see texture, it's mostly because it doesn't have a UV, so it doesn't know how to display texture. It doesn't know how to wrap a texture around your object, right? So you need to basically define a UV first, and then you can apply your texture. Okay, we don't need this. Now that we set our UV to our object, we can finally project our plate on top of it. Okay, so I set up a project 3D here that is basically connected to the source plate on one side, and it's connected to the camera that we tracked or that we got through the camera tracker on the other side. And I'm basically applying this project 3D to my object, and there we go. Okay, if I view this through my camera, I now have her face lined up or moving as the plate. Now let's turn off the lighting in the viewer so we just see the projection. And that's cool, but we still have basically the motion. Okay, we have the camera motion and we have the motion in her head, right? So in order to remove this motion, we need to extract the UV map from this object. And at this stage here, through this scanline render set to projection mode UV, we are actually getting exactly that. Okay, so don't focus too much on this dark spot. These are due to the weird topology that we are using. Okay, we actually just focus on this area here. So if we press play, we can see that our eye, or actually all the features that we have in this face, are pretty much stabilized. Okay, of course there is some distortion because our face is not rock solid. There are some distortions going on when muscles are moving underneath the skin, but overall our features are stable, and we remove the motion of the camera and the motion of our head. Okay, so we can use this texture now to basically replace the portion that we need to replace in our main plate here. Okay, so for speed purpose, I just render out this UV to my to an EXR sequence, so it's running faster. I'm not basically going or calculating all these nodes there. Now let's skip this merge for a moment and also this frame mold for a second. We're gonna see what they do later on. So now we have this texture here, and basically from this point onwards is just grading and masking and tracking. Okay, so let's go step by step. I basically apply a grade node that is balancing the changes in luminance. Okay, so right now we have our UV texture where the lighting is slightly changing. Okay, so I use this grade node to balance out a little bit the changes in lighting in the UV. Okay, and then there is some grading going on to match it closer to our source plate here. Okay, so some grading. I boost up a little bit the spec inner high or the reflection inner eye, and then I mask out just the patch that we need. And then I use a corner pin to basically position this in place. Okay, and I use the tracking data that I extracted here. I basically extract a transform match move baked, and I applied it here. Okay, it says stabilize simply because I invert a stabilize to use it as a match move, but technically this is a match move. Okay, so let's clear this out, and then I masked everything through the half of my glasses. Okay, so here we have the roto of the glass. Okay, and I basically masked out the patch using this roto here. All right, I don't care too much about, you know, the edges and stuff like that because they will be covered by the frame of the glasses anyway. So I don't care about these edges there. And then I comp it over. All right, and now we can check how it goes. So remember that now this is a live plate. Okay, this is the motion that we see here, inner high, is the same motion that we have in our UV. Okay, so this high here is this one there. Okay, it's the same. So this motion is the same that we have in our UV. And you see that there is some, you know, light changes, motion blur going on. So it's definitely not perfect. It's not ready to submit. But again, we're more focused on the technique here. Okay, cool. So we have this motion. In a moment, we're going to see how we can use some copycat trick to basically manually animate our high and match it closer to the other one, because the highlight you see in the other high is a little bit lower and we don't have it here, and there is no way we can fake it. We can somehow use some grid warp or some, again, warping technique to reposition this highlight, or we can use some copycat as well, just to, you know, get fancy. Anyway, after this we apply some glare and reflection to match it closer to the other one. Okay, and then we place the frame on top, and we're basically done. Now let's say that we want to art direct a little bit more our patch here, because remember, right now the movement that we see in our patch are coming directly from our UV map here. Okay, whatever is happening here will be translated in our final comp, right? So what if we want to somehow move our highlights independently, or maybe reposition our iris? Okay, of course we can try with some grid warp, some distortion technique, but I decided to see what we could do with copycat. So the basic idea behind all of that is I have my UV here. This is exactly the same as this one. Okay, it's the copy of this UV, And I basically went through the plate and I frame mold different frame, okay? From 1 till the end, till 75. So I basically selected different frame where the eyelids and the iris were in different position, okay? So I went through and I tried to select different frames that basically were showing different position of the eyelids and the eye itself. And again, I didn't spend too much time doing this, so I didn't train my model with a huge data set. There are like 14 frames, so it's pretty small, just to see what I could get out of it without spending too much time. And basically for each frame, I drew the corresponding roto shapes, okay? So we can see them in context in here. Okay, let's close that. So if I go on frame 1 and they start to cycle through the different frame, you see that basically these roto shapes here are matching the real crop plate that we have on the left. Okay, so this is what I'm trying to do. What I'm trying to do is at the end, I want to feed this into my inference node that is coming out of my copycat, so that I can get a crop of her eye that I can control with my shape. In other words, we are getting this. Let me just copy this out of my main script to show you. So basically here I have my my roto shape or my controller, and the inference node is giving me the corresponding eye. With the advantage now that I can literally control the position of my eyelids. Okay, and I can move my iris inside. Of course, something is changing outside as well, so it's not 100% accurate. The quality of the training is not super accurate. I didn't let it run for the suggested amount of iteration. I decided to just stop it when it was looking decent. It's not perfect, but it's looking decent. And again, the advantage of all of this is that now we can literally redirect our eye. Okay, so if we want to close more our eyelid, we can go at the end, for instance, and say, yeah, you know what, at the end I want my eyelid to be fully closed, you know, something like that. And you know, we can create this animation live. Okay. Once again, I'm repeating myself, I know, but I understand that the quality is very low, but the reason is that I didn't let this model to run through the suggested iteration. If I spend more time working on a bigger model with more frame to feed into the data set, we could get a better result. But that's nevertheless interesting to see. Like, we can literally create some motion that is not there. Okay, what we are doing here is literally converting these shapes into a semi-photoreal eye that we can then combine with our clean patch here. Okay, so to stress this out once again, what we are trying to do is how can we change the eyelid's position in a render plate. So this as baked motion that we cannot change, but with some copycat tricks, we can basically create a controller that once it's connected to an inference node, that basically it's the output of my copycat node after we run the training on several frame hold of my eye corresponding to different inputs. Okay. Once I get this node here, I can plug this controller into my inference node, and whatever I do to this node here, I get the output. Okay, I get basically the corresponding photoreal output. Okay, and that's pretty nice. Honestly, it's really like magic, you know. So to cut it short, what I wanted to do here is basically trying to find a method to lower my eyelid, and that's exactly what I did. I basically used this controller down there. I plug it through an inference node. Okay, the inference node that comes out of my copycat here. Okay, some sharpenings, some tweaking, and then I basically comp it over the real high. So this is the real high, and this is the inference I that is coming out of the inference node. Okay, so we're basically using this, okay, through an inference node to replace the real high. And now, if we track it down here, you see that we can literally control how my eyelid is closing. Okay, I create some keyframe here. So basically, at the end, I want my eyelid to be slightly closer, or to match more the other one. Okay, it was more open before, and if I press play now, it's it's closing down at the end of the shot. Okay, this motion that you see there, okay, is coming from the rotor shape, and it's live. So if I want my eyelid to be more open at the end, I can go here and I can open my eye, and my talent is opening her eye basically. And that's cool. That's cool. I mean, the idea, the principle behind it, it's very nice. Obviously, the execution is not that fine. I mean, I should have worked more on this. But ideally, the concept is very nice. You can literally hard direct a different portion of your actor face with this type of approach. And that's pretty much it. This is how I basically rebuilt the high underneath the reflection, combining a bunch of different technique and some copycat trickery. I hope you like it, and I hope that it helped you to somehow better understand certain techniques or new nodes that maybe you never used before or not that much. And if you have any question, as usual, feel free to reach out anytime. If you have any advices, suggestion, the same. And other than that, I wish you a pleasant week and speak to you soon. Bye-bye.